Okay, we start up again. Continuing with this changing of the openFOAM source code in openFOAM. Now, some of you may have the location somewhere different. Here I just copied from my setup. If you are wondering where the heck is my source code, then you can use find. But then, of course, first of all, it depends on your setup. Where are your openFOAM files? Where are they located? In many of you, I think they are located under /opt. I have mine under user lib, openFOAM and something like that. So let me show you. You can use the command find. And then you have to tell him where to search. So here, for many of you, you will then have /opt. I must write user lib openFOAM or something like that. openFOAM. That's my location for my installation. Then what to search for? Minus type. I want to search for a file. And then finally, minus name. And the name should then be openFOAM, and then period big C for the C++ code. That one should give you the location for where he can find this openFOAM.c. And you can see here, you have the entire address here, solver incompressible openFOAM. So you make a copy of that address, Control C, and then you write cp minus -r, and then you just glue in everything, space, period. Now I can't do it because I've done it once already. But I mean, that's the way you can locate, where is my source code? Where is my source code? Okay. So use the find function. That is a nice little program if you have trouble locating where is my source codes. Let's see now. We were dealing with gedit. We had changed the make and then the files. Like that. I have changed it from foam underscore appbin to foam user appbin. And that's the only change there is. The other file here, that was called options. And yeah, they include some libraries and stuff. I mean, this is a little bit messy with C++. He can use object files, he can use library files, and then in the end link all these pieces together to one executable. Can be a little bit messy. So don't mess around with these addresses unless you know what you're doing. Okay, then we go into our source code. That was under openFOAM, and it was openFOAM.c. Here you have the main program for the openFOAM. And you see all the blue here, that's just commented out. So we have to go all the way down here to get some information. Here we have the first actual executable statements. But you get some information on what the heck he's doing here. So looking inside the source codes, yeah, that can be a good idea. Now let's see what he does. Let's see what he does. He includes a lot of header files here, which we are not going to mess around with. Then he has an info system. This info system, that is what you will see on the screen when you are simulating, when you are running a program. All the output, yeah, that would be through this info system. So here you see you have a sentence, /n meaning new line, and then he's sort of piping this string into the info system, and then finally also an end of line. And then here we have the main loop, the time loop in openFOAM. While a runtime loop, do. So that's sort of the heart of openFOAM. And yes, he starts by printing out the time. He finds the time from the system. Fair enough. We have some Courant number thing here. Okay, makes sense. And then here we have actually our entire equation. What do you know? Very easy. Time derivative, nonlinear terms, and then we have a Laplacian. We should have some pressure as well. Well, that is in this piezo algorithm. So he starts first calculating without the pressure. But I mean, this is the simple setup. Simple or piezo or pimple if you like. You guess a pressure, 0, and then you create a velocity field. Tentative is wrong, but you have to start somewhere. And then you adjust pressure and velocity until continuity is fulfilled. That's sort of the recipe here. Actually, he has taken the old pressure here, if you have it. So solve the U equation, this one, equals the negative pressure gradient. Makes sense. So now we are not going to change anything of this. And we are inside the piezo correct. And then we have even non-orthogonal correctors here as well. Okay. Continuing down here. Then finally down here. Runtime, write out the time. And then this will then be the end of the main time loop. And also he has some more info to print out here, fair enough. So here I'm now going to add something inside this code. Here. Here I want to find the velocity in our cavity simulation just under the moving wall. So here I'm going to need a location. I'm going to need a location. And yeah, that one is a vector. And I just call him location. Vector location. And the vector location, that should then be 0.05. That was the x. And then it was 0.099 or something like that in the y direction. And then the z should be in the center, 0.005. Here we go. So this is then just the location given one single point. Okay. Then we have to connect that one into a cell. I have to find the closest cell to this location. We have a function there inside openFOAM. He can now create a label. What should we call him? A cell ID, for instance, something like that. So I will invent here the identity of the closest cell to this location using the function is called mesh dot finding or find nearest cell to the address location or the position location. There we have it. Oh, it should be mesh. Something like that. Yeah. So luckily the guys who nearest cell, I think it's correct. The guys who have programmed this one, they have the sense to create sensible names for the variables of the different functions. In the old days, when you write a program like this one would be called A1B6. Doesn't make anything sense, so it's impossible to read. But this one is more sensible. Yeah.
Is there some sort of list of all the functions that are available?
Be my guest. I don't know. I haven't seen it, but that's going to be a long list. Trust me. Yeah.
How do you know that that function exists?
Luckily, I find this recipe on the net. Okay. So typically, yeah, you search for it. But I mean, to guess this name, of course, you can't do that. Somebody has to tell you that. But finding all of them, brrr, that's a tough one. That's a tough one. So now you have to find, say, somebody has done something similar and steal whatever they have done, so you get an idea. That's the only way to survive here. Okay. So at this point now I have the cell identity of the closest cell to this location, hopefully. Then, what do I want? I want to have the value printed out, so I'm going to use the same info system that he also uses here. Print out a lot of information on the screen while simulating. That's nice. So the location of the notation info, and then a double arrow, meaning you pipe into the info system. If you only use one arrow, that's not good. He will then erase everything that was there already. Double, he will append. That's the same as if you put something into a file. If you use only one, he will create a new file or destroy the old one. If you use double, he will append to or continue writing into the file if it existed already. So what should we call this one now? I have to give him something sensible text string. What should we call him? My point, whatever. My point. And then I want to have the time equals, and then I stop there. So then this text string is then going to be put out into the info. Okay. Then I want to have the time. I want to have that in the same sentence. And that one, the time, is called runtime, big T, runtime, period, time, name. And then just an empty bracket there, something like that. Then I have the time, and then I want a velocity. Continuing here. If you don't use a semicolon, then you just continue on the next line. So that's fair enough. Now I want to put in the value of my velocity. And, well, we can give him a name. U sub x equals something like that. That should be a nice printout. Now for the actual value for the velocity. It's a big U, and then we have to use square brackets. And the address, that is my cell ID. There's a big D there, like that. So he will look up in the cell number, finding the velocity. But remember, U, that's the vector. That's all three velocity components. I only want the horizontal dot x. Then an empty bracket. And then we finalize this one with end of line. Something like that. That should be it. So these 4 sentences, that's all I have changed in the source code. Any questions to that one? I'll put this one out for you when my PC starts finding the internet again. Let's try. I save that one. And then comes the million-dollar question. I want to now compile and link and get a new executable. That's the whole point here. I'm standing in the correct address under my own personal openFOAM area. And you don't use make in openFOAM. You use wmake. So the make, that was the system where he can detect which subprograms need to be compiled, and then he does it for you. wmake, that's even more advanced. That is sort of only for openFOAM. So wmake, he will do everything for you. Let's see what happens. You have a lot of fancy printout here, which is not humanly possible to understand. The only thing you have to look for now is an error. Did we get an error? No, I don't think so. meaning it should have been worked okay. If it worked okay, now I have an icofoam of my own. That means on my machine I have now two different icofoams. Which one will he use? Which one will he use? Interesting. Let's try this one. I'll go back to my run folder, go into my cavity folder. Here I have the default setup for the cavity case. I can write block mesh. That was wrong. Block mesh. Thank you. Here we are. So yeah, it's my cute little box here, 0.1, 0.1, 0.01 in the Z direction, and I have 5 by 5 cells. Oh, it's a very crude one. Never mind. Then to simulate. Which program is he going to use? You check that, writing which icofoam. That one will report to you. Where do you find the program called icofoam? Let's have a look. It's found under Home Radar. Aha, it's my personal private one. This is where he finds, or he's going to take the icofoam. So let's run it. Icofoam. Very fast indeed. And yes, you see, I have received my sentence exactly as I ordered. Perfect. Piece of cake. Now you know how to program openFOAM. Yeah, one thing while we're here. Say now, I want to plot this velocity here, just under the moving ceiling, as a function of time. How can you do that? Well, first of all, you simulate, but then don't let the output just go onto the screen. Just shuffle all the output into a file, any file name, just a text file, a.a, whatever you want to call him. So now, you see you don't see anything, but now I have created a text file called a.a. Right here, 77 kilobytes. And then I can flush this file, a.a, on the screen if I want to. So here you have the exact same printout, but now it's stored in a text file. And now we can start playing around with that one. So yeah, you can cat the file on the screen, but then you can start using some filters. You pipe, and then you write grep, and then I can say, use a unique word here, my point, like that. He will then filter out the text here, and then return only the sentences that has the word my point into it. So then you have this one, and then we can continue. We can even take another pipe, and then I'm going to cut this sentence up into several pieces. To differ between the pieces, I'm going to use the space. So what was that? Minus D, I think it was. And then you have a string here, which then defines how are you going to split up this string. So I'm going to use space. And then I want to have a printout, minus F. And then you just write the numbers where you want the printout. How many do we have here? Here is 1, and then I have a space, 2, space, 3, space. This is number 4, that's the time. I want number 4. And then I have space, number 5, space, number 6, space, number 7, comma 7. So I take number 4 and number 7 of that string, and I get exactly what I want. Now I have time versus velocity. And that one, say you want to plot that one or something, of course then instead of flushing it out on the screen, you just pipe that one into another file. b.b or whatever you want to call him. Then you have a text file with the data you need. So that's one way to filter out the essential information that you are interested in. Any questions to that one? Yeah.
Where in the source code does like the boundary conditions and stuff?
Oh, they are hidden there somewhere. But you saw in the source code here, where are we? Here. He didn't say anything about boundary conditions, at least not at first glance. But they must be here. At every time step, they should be. Okay, let's see if we can find it. Where do we start here? Include QRA number, makes sense. Then can we find anything else include here? No. Well, we have continuity errors, okay, nice. But no, nowhere here we can find any boundary conditions. Where are they? I mean, if you look at the programming language, I mean, here you have the entire Navier-Stokes in one sentence. Of course, these functions here, they have sub-functions, they have sub-sub-functions somewhere in there. Yes, you're going to find it. Be my guest. So, no, they are there, of course they are. But I mean, it's really high-level programming, so you only see the top of the iceberg. Whatever is hidden beneath, you have to find yourself. You have a system, it's called Doxygen, where they recommend if you really want to play into these source codes. So there you can find a lot of help, I think. And also Google, of course. But the Doxygen system should be okay. Other questions? Yeah.
Is it easy to just like put in openFOAM that every time that it should run the block mesh once again or something, like execute wall functions?
Then I would do it differently. No, I don't think you can do that one inside the main program. Then I would have created a batch script, block mesh, and then change the entry into control dict to run one time step, and then repeat new block mesh, new run. You have to do that one in a script. I don't think you can do that in the program. I can't see how that one can be done. Maybe it's possible, but I'm not good enough in C++ to do that. So tell me when you succeed. Other questions? Yeah.
If you run openFOAM for another case, isn't you only use this setup?
Yes, and if you are in doubt, you always check that one with which openFOAM. So now let's do some nasty one. Which openFOAM? openFOAM. Here we are. So as I said now, under which openFOAM, he reports my home address and then my personal, thank you, I didn't invent this name, but never mind. So here my binary files are going to be stored. Okay, let's delete it. I'm going to remove that one. I kill it. Kill it. Copy the entire address. Now that file doesn't exist anymore. Now what's going to happen? Okay, I run again. openFOAM. The program doesn't exist. No such program. So now I sort of, ooh, have I destroyed my openFOAM? No, no, no. First of all, if I now had killed this terminal and then created another terminal, he will detect the change and go back to the original. That's one way to do it. Another way here, I can do the following. If I again write which openFOAM, the which system, he will detect the change. So now you see all of a sudden which openFOAM, now he's back to the original, user lib openFOAM. That's not my private one, that's the original. And then I can just execute that one. Just copy the entire address. Instead of writing openFOAM, you write the entire address, Control C, and run. And now you see you don't have this printout anymore. This is the original. So it's very easy, sort of, you create something and then you change your mind, just destroy it. No problem. I mean, openFOAM is built for this. Play around with your own version of your source codes. Yeah.
So if you want to use one definition for openFOAM or one case setup, and the source code definition, can you specify that without deleting the file?
I'll show you. Yeah. Yes?
Same question.
Same question. Okay. So let's do this differently then. Let's go back to the files and the changes and everything. Here I had my local version of openFOAM. I had then put in these sentences here. I want this printout. Fair enough. I still call him openFOAM, and I still are in the same address under application solvers incompressible openFOAM. I'm still here playing around with these files, but I don't change them now. But inside this make folder, there we had a file called files. Here we are. The openFOAM.c, that's the name of the input file. The executable name, ooh, here we can be creative. Of course, he doesn't have to be called openFOAM. He has to be called RadarFOAM, of course. Very good. So now let's try that one. Save. And then I just try to run, what was the command? wmake. He does all the job for you. wmake. Let's see now. wmake. That one went extremely fast, dangerously fast. But I think he has done a lot of the jobs already, so they're hidden here. But you see, no errors. Just to show you, that's important. Let's do something stupid here. I forget this comma. Save. And then I try to run wmake again. Yeah, you get something. And I mean, again, it's not humanly readable, but at the end, error 1. And then you have to try to find it. And yeah, what do you call it? Too much information. But somewhere up here, he should say, yeah, here you have a mismatched type, so actually he found it. But reading error messages, no, that's not fun. Let's go back here with the comma and then remake it, wmake, and now it takes some more time. So it's actually possible to download the entire openFOAM, all the programs, and then you can compile everything yourself on your own computer. You're going to spend some days compiling. It takes a long, long time. Millions of code lines, so a little bit tricky. Okay, let's try that one now. Run, change directory to the cavity, and yeah, we can just leave the files, doesn't matter. And now I want to simulate again using RadarFOAM. Yay, there you have it. So now you have your own personal name. That might be smarter instead of using the same original name when you have in conflict with openFOAM system. So you can call him whatever you want. Very easy setup there. Okay. Any questions to that one? That's okay. And now, when you have created this program of yours, you can go back to the this folder where you have the run and you have the applications inside here then I have my source code and the entire icofoam that I have been changing. So if I now do something very crude, let's see now, I close the editor and then I simply remove everything. I remove my playground with all the source codes and everything, just destroy it, like that. As I said, with Linux, you don't get a warning. Are you sure you want to do this? Are you really sure? You don't get that kind of questions. It's not done. Now they are gone, and they are gone forever. So now the source code is gone. It's away. But I still have my radar.foam. I haven't destroyed the program. The executable is still present. Here, of course, they didn't find any programs to run, but the program is still operative. All the way, all the time until you destroy it. And you can check again which radar.foam. Then he should report, yes, it's in your personal private area within the binary location there. Okay, that was fairly easy, just one single small change in icofoam. No questions to that one. I'm going to continue tomorrow. Then I'm going to add, say, a new equation inside icofoam. I want to have the temperature. So how to put in a new equation inside a given source code. So that will be then the topic for tomorrow. This programming thing might not be needed for you guys, but I think it's nice to know. And the important thing here, openFOAM is built for this, that you can play, change, do a lot of stupid things, and you don't destroy the originals. You always take a copy of the originals. That's the essential point here. Okay, no questions? Then we stop here.